thank you. A little bit about us. My name is Maria Lucena. I've been a Director of Architecture at Fidelity for about 10 years now. The last 2 specifically working with Federation. This is my second summit talk. The first one didn't scare me enough, so I'm back for more. Thanks. Benjamin.
Hey everyone, I'm Ben Dixon. I lead the Application Integration Architecture team at Fidelity. We work on standards and patterns and governance for APIs and experiences.
Hi, I'm Krishna Bhupati. I'm part of our Unified Developer Experience Architecture team. We work on solutions to simplify our technology landscape and also reduce the cognitive load on our developers.
Great, so we're going to be talking today about the RFC process and how it enables collaboration and then the derived outputs from that. We're going to start with the RFC process specifically at Fidelity, which is the why and what. Then we're going to be covering a couple of examples that showcase really well what we have accomplished. Before we get going, let's do a little show of hands. We know it's late in the afternoon, you want to go home, so let's just get you a little awakened before we start hitting you with information. So I'm going to ask a question, keep your hands up. And let's see what happens. Who here has ever used Angular or React? Hands, good. Who here has ever used GraphQL? Keep your hands up. GraphQL, okay. Those that don't have their hands up, I don't know what you're doing here, but if you have, you've already come across a platform that benefits from the RFC process. One more. Who here, in the context of work, has ever had issues fleshing out an idea with a large group? Keep your hand up. There you go. Who here has struggled making a decision with your teams? All right, who here has ever had a difficulty getting a message across? All right, a lot of you are doing really well. For those of you that are suffering, I'm glad to hear that because we have something that hopefully will help you with that. Alrighty, so the RFC process at Fidelity. Let's start with the why. Fidelity Investments is a large organization that offers a multitude of financial services. Given the breadth of those services, it is divided into multiple business units with numerous teams and thousands of developers. At the firm, we have been using GraphQL for some time. The Federation process was introduced most recently, but monoliths have been around for longer in production. Typically, those teams develop those monoliths in isolation, and now that we're introducing the Federation process, they need to get the buy-in from the enterprise as they develop their capabilities so that there can be more consistent standards and patterns. So it is no longer a nice to have, but a fundamental requirement that we get all those disparate graphs working in unison for the supergraph. As we were going through this transformation process, we were having a lot of different conversations, making decisions on the fly, not remembering what we decided, what we talked about. So we realized we needed a process where we could capture those conversations, flesh them out better, then potentially turn those documents into beautiful standards that the enterprise could adopt. And while that may sound a little aspirational, we realized that the open source community was already doing a lot like this, so we just needed to look into it and find a tool that would work for us. And after some research, we came across RFCs and realized this is what we needed. So what are RFCs? Requests for comments are a tool that technical teams use to share and develop their ideas, processes, designs, and whatever other things, and document them in the process. So the purpose of this type of written interaction has always been to enable dialogue without the formality of other formats. This idea actually came to a team that was working on an ARPANET research project. They had notes, they needed feedback, and so they came up with the document that you see here. Document conventions is RFC number 3, has been around since 1969, so it's pretty cool. You can still find it. This document captures the essence of what we're trying to achieve, which is to, again, there are 2 main reasons why they wrote this document convention. The first is to challenge the notion that the written statement is always authoritative. They wanted to foster an environment where dialogue, where ideas could be easily exchanged and just fleshed out. The second being to challenge that hesitancy to publish something that is not completely polished. So this is very true today. Put in other words, RFCs are a way of bringing raw ideas to the table, polish them through dialogue, making a decision as a group, and then having a nice historical reference of that rationale. They do enable collaboration. They remove a single point of failure because now you're making decisions as a group, and you will have vetted and educated solutions at the end. So how did we realize this? We, again, keep staying with the sentiment of keeping things uncomplicated. We relied on another source that is quite common to the open source community, GitHub issues. That provided us with the platform for just anyone to come in, create an RFC, and then store that, and maintenance was just a given. It was already approved by the enterprise. As you can see, the template is quite self-explanatory. There's a title, there's a section with the problem space where the problem statement will be filled out, the solution space, and then a nice label to just find these issues easier in GitHub. All authors have to worry about is to follow company communication policies and make sure they add the context that they need and leverage the visual tools supported by GitHub. This is simple but very effective. Now this is the RFC process end to end. It starts with opening an RFC. We take that artifact, we share it, blast it to the community. We make sure that relevant people are looking at it and commenting on it. Then comes the async comment part. Here's where we refine the problem space and we explore different solutions. We get people from diverse backgrounds, experiences, and it is really enlightening for all of those involved. Sometimes there are things that we don't consider that come up through this async comment process. Then depending on the use case, we may take this to review internally with different teams. If it warrants that we do that, collect any feedback, retrofit it, and then close the RFC. There are action items, we jot them down and work with them because they can take time to complete. There are things like updating tools, updating documents, codifying a document so that it can become an enterprise standard, and that can be a little lengthy. Another one is asking Apollo to help us out with that feature. So we have collected over the last few months quite a decent archive of RFCs. There are a couple that we feel demonstrate really well the process end to end. One is in the engineering space, another one in the consumer space. Yes, Ben?
All right.
Thanks.
Okay, yeah, so I want to walk us through a specific RFC that we had at Fidelity so that you can kind of understand the mechanics of the process through the example, and then also get into some of the technical discussion that we had within the RFC itself. So this is a real RFC that we had at Fidelity. The title is Error Handling in Nullable Fields, and I think the first thing that jumps out at you is it's pretty short. This isn't like, we're not asking for a dissertation here. As Maria mentioned, one of the big things we're trying to accomplish is just get the discussion started. We don't need a polished artifact. So we have the problem space, and you can see we don't have a solution space in this one, so that's also okay. We get some question marks there. A specific example is brought up in how we at Fidelity have different error handling responses across business units. So the way we do return error codes, basically there's no standard across business units. And specifically with how we return authorization, in some cases we'll return something like a 404, in other cases we'll return a 403. There is an actual question, so we have that kind of specific example, but the question is pretty broad, and it's just how are we going to create a unified interface for our consumers, which is our supergraph, when we have such fundamental differences between our business units and how we do something as simple as returning errors. So the first step that Maria talked about was that async feedback step, which is really just a fancy way of saying we leave a lot of comments in GitHub. This one, we had 31 comments and 12 participants, and I would say this is what very good engagement looks like for us. So don't expect, a ton of comments and then set yourself up for disappointment. But it is, I think, just as important to see who does weigh in and who doesn't weigh in. When people come back 6 months later and ask why you established some standard, you can point them back to the RFC and say, here are all the people that participated. Yeah, so for this one, I think we kind of quickly coalesced around the idea that there was just a misconception between RESTful URIs and GraphQL queries. So with RESTful URIs, you may leak information about the existence of a resource depending on the error code you return. But typically, you don't have that issue with GraphQL queries. So the user already knows the fields that they're querying for, and returning an error code or null for that field doesn't necessarily indicate that there's data or not behind it. So before we jump into the actual discussion and technical conversation we had in the RFC, I do want to highlight what we've done so far, and that is create an open dialogue with representation across the firm. So the big thing here is among those 12 participants, there were people across a lot of different business units at Fidelity. So these people don't, on a typical day, work together. But this is really critical when we have these issues that arise out of cross-enterprise complexity. You want that kind of diverse set of opinions weighing in and having that those unique perspectives as well. But like I said, we do get to see some actual schema here. So some of the discussion we had within the RFC itself, once we kind of aligned on the fact that, yeah, there's this difference between RESTful resources and GraphQL queries, we can return null. Then questions kind of popped up of, okay, well, when should we actually define a nullable type versus a non-nullable type? And the example on the right here shows a customer type that has a middle name of string. It's a nullable string. And we can, if a new business rule comes in that says, actually, every customer needs to have a middle name, it's critical for some business functionality, we can easily update the schema and enforce that constraint with a not null field. We haven't impacted any clients. We haven't introduced a breaking change. We were able to evolve the schema gracefully. The reverse is not true, right? If you start out with a not nullable field, and then you realize actually 5% of our customers don't have a middle name on record, you can't go out and change that schema without affecting all of your clients and introducing a breaking change. The other thing we talked about within the RFC was this concept of not nullable fields causing errors to bubble up. And so the example on the right here shows a customer type with a personal information field and a contact information field. The contact info, both of them are not nullable in the schema. And the contact information type has emails, phones, and legal address, and that legal address is also not nullable. Which is fine, except maybe that legal address comes from a different data source, and for whatever reason, you get an error and a null back from that subgraph or API. Maybe there was a network glitch, maybe you're unauthorized, any number of reasons. And again, that's cool, except we just told our consumers that we would never return null for legal address, which means we have to null out the entire contact info field. So even if we were able to successfully retrieve emails, the user is never going to see that. Also good, except we told them that we would never return a null contact info field. So again, we have to null out now the entire customer object, even if we were able to successfully retrieve some of the other data. So obviously, this is hindering our ability to return partial responses, which is one of the benefits that we really liked about GraphQL in the first place. And so within the RFC, we kind of landed on this general rule, which was prefer nullable fields. And there's an asterisk here. Unless you're protecting a business invariant. So if you have some business rule that you cannot violate and it would be violated by returning null, then sure, not null makes sense. But in general, we can prefer nullable fields. So then within the RFC conversation, and again, these things kind of take sometimes an organic flow like this, which is always good and encouraged. The question was raised, okay, well, when should we actually return null? Because we have a choice. We can return null, which is kind of JSON and GraphQL's native way of indicating that there's no data for a field. But we could also return a zero value. And if you're not familiar with that concept, it's just the idea that you can return a default value for fields that haven't been initialized or don't have data. And if that still doesn't make sense, I think the example on the right here explains it pretty well, which is, maybe you have, again, a middle name that's a string. You can return null if there's no data for that field. But what if a customer has no accounts? In that case, we could return null, or we could return an empty list. And within the RFC, we had folks weighing in from our experienced teams, and essentially where we landed was 0 values for aggregate types are just a little bit easier to work with. You can iterate 0 times over an empty list, things like that. So we amended our rule, and we said, OK, prefer nullable fields and useful 0 values with our little asterisk still present. And then we took that one step further, and within the RFC, we agreed upon this decision matrix to say, OK, scalars and value object types, make sense to return null. It's kind of confusing for consumers when you return 0 for an integer or an empty string. So yes, null makes sense there. But for aggregate types like lists and connection types, if you're following the relay cursor connection specification, and namespace types, 0 values are pretty handy and easy to work with for consumers. So we created this decision matrix. And then we were able to close out our RFC, and what we're always looking for with these things is actionable or tangible outcomes. And so in this case, we were able to update some internal documentation to basically better explain nullability, and then also update our enterprise standards with our general rule about preferring nullable fields and useful 0 values, and then updating our standards doc with that decision matrix. So hopefully going forward, it's more efficient for engineers. They don't need to rehash this whole conversation. They can refer to that table, make a choice, and move on. All right, so I'm going to hand it over to Krishna. Talk about another RFC.
Thank you, Ben. So I'm going to talk about another RFC that's resulted in a customer identifiers pattern. Standards and patterns are very critical for us because it brings consistency to our supergraph. This particular RFC addresses a problem we had at Fidelity dealing with multiple customer identifiers across our business units. But before we dig into the RFC, I want to compare this with what Ben has shared. Obviously, this RFC is a lot more verbose. I wish you can see a little bit more details there, but also it's verbose because it has a lot more details that help better understand the problem, with diagrams, with code snippets, and also schema examples. So I just want to highlight that our RFCs take different shapes and forms. Now let's understand the problem space. So at Fidelity, we have different business units. If you have or if you are a customer with Fidelity, either from your employer or from you have a personal accounts, you're talking to 2 different business units, because at Fidelity, we have many business units that have different customer capabilities. They have evolved organically over the years, sometime over decades. And they have their own tech stack and unique view of our customer. And I'm sure this might be a case in many organizations. That could be because of acquisitions, or to maintain the autonomy, the organization may have decided to have that space. But now we want the business is asking to create more unified experiences across all the capabilities where there is an overlap. At the surface, this is a great use case for federation. We just need to rename few boxes, and we are good. Actually, that's the gist of one of the comments on this RFC, but it's not that straightforward for us. As I mentioned, we have different business units, and as the user is moving from one experience to other experience, we have to convert the session to the respective business unit identifiers. And the logic to convert this, how this mapping is spread across our API ecosystem. As you can see, different business units have their respective identifiers and APIs to have that mapping. Usually, federation works on the notion that we have a shared experience, shared primary key, but as you can see, that's not the case for us. So now let's discuss about the solution space. So we wanted a solution that works for both for our customers and also our subgraph providers, where it's much easy to use, and also it's a common mapping service across our supergraph. And also we want a declarative solution. So we started with one single entry point to our supergraph. As you can see, the customer entity. And then we added a customer identifiers field. What it enabled us is to actually create a mapping resolver to map the session to the different identifiers I was discussing about. And I want to discuss about the highlighted inaccessible directive. What this directive tells the router is like this particular field cannot be viewed from the consumers, so they cannot actually query for this field. It is just a server-side linking construct that subgraph can use and rely upon. Now, in this RFC process, we got a lot of feedback, and we understood more use cases, and then we decided like we need to have another entry point. The customer entry point here is used for consumer applications, and the customer by ID is for our internal applications. As you can see, both of them are returned the customer entity. So given that we decouple the auth context from the resource identifier, if a subgraph is actually contributing fields to the customer entity, just because the entry point is different, we don't need to change any of the implementation. And also, I just want to highlight that given this is a federated environment, all those identifiers can be contributed by different business units. How does this actually work in the subgraphs? Let's take this example where on the left-hand side we have a subgraph that is provided by business unit X, and on the right we have another subgraph from Y. Both needs their respective identifiers to contribute fields. The X is contributing personal information to the customer entity, and on the right we have employer information to the that's been provided by business unit Y. So they just need to annotate these fields with the identifiers they require with using the @requires directive. What this tells the router is to invoke the mapping service that we actually saw in the previous subgraph, and then as a developer, I just need to say, I need the particular identifier, I don't care how you get it, and it's the router job to actually invoke the resolver and get that field. And I also want to take a note of how simple and declarative this is, right? From a developer point of view, they just need to focus on the shape of the graph and not worry about the mapping between different fields. So the solution, in the solution space, what we also found out is the query actually is a lot more natural now to use. We have a good customer namespace where it's much easier to find these fields, understand how they are related, and not worry about this mapping of different identifiers. And this identifiers mapping we discussed is opaque to the consumers also. They doesn't need to know about it. And as we change the implementation, because they are unaware of it, there's no impact to the consumers. So in summary, if we have a use cases like this where you have an entity that is spread across different systems, but you need to map those identifiers, you can use this pattern to map IDs across different systems. So at the end of this RFC, we got a good feedback and we came to a good solution. So we updated our reference implementation where this is a space where our developers can see how this pattern is used and actually implement in their own subgraphs. We also documented this in our internal developer documentation.
So we have been doing this for about a year now. We are pretty happy with the results and with the process that we have in place. There are at least 20 RFCs that have been produced from the different interactions with 66 participants, 5 different business units involved in that process. While those numbers may not seem that large, it is a relatively new process, and we are still growing. The GraphQL community is still growing. So far, so good, and we will continue to do this. We do have a supergraph in production that was released recently, and that supergraph leveraged some of these documents. Thank you all for being here. We hope you like what you see and come to find us.